Hello everyone. In this video I'm going to be reviewing interval notation and going over the basics on how we can convert from an inequality to interval notation. Let's start with these two examples. When I say x is greater than or equal to -3, and regardless of how we got to this point, this is the answer that we're left with. To put this in interval notation, we have to decide in this interval, when we're saying everything's bigger than -3, what's the lowest value we can have and what's the highest value we can have. Because that's how we do interval notation. We have our lowest value, and then our highest value, on the left and on the right, between parentheses or brackets, and I'll get to that in a second. So again, we need our lowest value, which we'll put on the left, and our highest value, which we'll put on the right. So if x is greater than or equal to -3, it helps me to put it in the form of a number line first. So in number line form, I'll mark my -3. Now, if you remember, if I'm trying to say x is everything that's greater than or equal to -3, we have to decide which way are we going. Is it to the right or to the left? And in general, remember that on the right side refers to anything greater than, left side anything less than whatever value we're talking about. So in this case, I want my arrow to point to the right, since I'm talking about greater than. Now, depending on how you learned this, there are two ways of writing this. The first is we can put a closed circle if you did closed and open circles. The other way is to put a bracket, like so. I'm going to use brackets and parentheses, which you'll see next, because that's naturally used with our interval notation. But just as a quick review, a bracket is the same thing as a closed circle. A parenthesis is the same thing as an open circle. Those of you who are familiar with open and closed circles. So based on this graph, we can see that there's nothing lower than -3. There's no value that's less than it. So that's going to be our lowest value. And since it's greater than or equal to, that's why we put a bracket. We get a bracket here for -3. So again, because it was greater than or equal to specifically, that's when it get a bracket. If it was greater than but not equal to, it would get a parenthesis. Now, since we're talking about going higher and higher and higher with our values, there's no highest point here. We go to infinity, so we say simply that, infinity. And infinity, whether positive or negative, always gets a parenthesis, since it's not a specific value. It's more of a representation. And here's our interval notation. Let's try it again for x is less than 4. Helps me to put a number line. Now, if you want just the straight interval notation, you don't necessarily need the number line. It's just something I use for a visual reference. There's my 4. Everything less than 4 will be smaller, so it's going to go to the left. So I have my arrow pointing to the left, and I'm going to use my parenthesis because it's less than but not equal to. So again, if it had been less than and equal to, we would put a bracket. Now, looking at my numbers, there's nothing less than, nothing greater than 4, as we can see. Just visually in the graph, nothing is higher than 4. So 4 is now going to go on the right side as our highest value. And again, it gets a parenthesis since it's less than but not equal to 4. Since we're going to the left, everything is less than 4, so we have a negative infinity. and infinity always gets a parenthesis. So we have our interval notation. So these are the two basic types of interval notation that we have when we're talking about both of these are not compound inequalities, they're your basic linear inequalities. But let's look at a generalization. Let's see if we can find one. Basically, I'm going to put down a few intervals. X is greater than or equal to 3. The numbers don't matter. X is less than or equal to -5. X is greater than, let's say 7, and it's supposed to be 7. And let's say X is less than 2. So in interval notation, let me write these, and let's see if we can find a general pattern. When X is greater than or equal to 3, 3 is going to be my lowest. Positive infinity is my highest. X is less than or equal to -5. Negative infinity is my lowest. -5 is my highest. X is greater than 7. 7 is my lowest. Infinity is the highest. X is less than 2. Negative infinity is the lowest. And let's try that again. 2 is our highest value. Now the point is, notice each of these, and let me see if I can do a, let me see if I can make these a little more, stand out just a little bit more. Let's see, let's get so that's my highlight tool. It doesn't look too good. Let's get rid of that. Let's just use the basics of circling. So, attempt number 2, that's a lot better. Notice my two intervals that are greater than or equal to. For each one of these, the infinity sign is on the right, the number itself is on the left. That's a nice little generalization you can use. Likewise, with my less than symbols, infinity, or I should say negative infinity is on the left, the number's on the right. It's a good generalization you can use to make sure you're following the right format. Now the precaution. This works because, notice the order that I have this. In each one of these, X is always on the left. That doesn't mean, for example, in the first one, if I had instead written 3 is less than or equal to X, it would still be the same answer. But as a general rule, what I'm telling you now, when it's greater than, the numbers are on the left, infinity's on the right. When it's less than, infinity on the left, numbers on the right. That works because of the setup that I have here. When you solve it, when you simplify your expression, X is on the left.